Hello guys, welcome back to this channel. In this very video, I'm going to share with you how to hold on a circuit using electromagnetic relay. This is a practical video, so from here we are going to practically build such a circuit. This is how electromagnetic relay looks like. Basically, this is the coil of the electromagnetic relay and this is the base or the socket. Altogether, we call it electromagnetic relay. But this is the coil and this is the socket or the base. Now, on the socket, we have numbers, and on this side, that is the coil side, we have the wiring diagram here. So if you want to have a clear understanding of electromagnetic relay, then you have to learn the wiring diagram we have on the side here. That is what is going to guide you to build whatever circuit you want to build. And before we start with the wiring diagram of the circuit that I'm going to talk about, I'll first of all draw the wiring diagram that we have on the relay. This is the relay wiring diagram. We have it on the side here. And electromagnetic relay is an electrically operated switch that uses electromagnets to control the opening and the closing of electrical contact. That is what electromagnetic relay is. I have the wiring diagram on a paper here. So what I'll do is to look at the wiring diagram that I've drew on the paper and then draw it on the board. We have it here, but it is very small, so I've drew everything here. I'm going to look at it and then draw it on the board too. Before you understand the working principle of electromagnetic relay, you have to first of all understand the drawing. It is very important. That is what is going to guide you. So what I will do is to look at it and then draw it on the board. Now we have 5 amps and then 250 volts AC. This is the maximum current rating of the electromagnetic relay, and over here is the coil voltage. In order for us to energize the relay, you have to supply the coil contacts with 250 volts AC. That's the maximum voltage. It could be 220, 230, 240, and the maximum is 250. This is number 9. This is 11. I have 1 here. This is 12. I have 5 here. I have 14. I have number 4 here. So that is 42. This is number 8. Number 12, here is 41. You have the coil itself. I have 13 here. 13 is A1. This is the live. You have A2 at this side. This side is 14. That is the neutral. Now this wiring diagram, the only thing that you have to be doing is to focus on the numbers in the brackets. That is the numbers that we have on this socket or this base. So you have to be focusing on the numbers in the brackets. We have number 14 and number 13. And on the relay coil, number 13, that is A1. We have it here. Number 13 is A1, that is the live. And number 14 is A2, that is the neutral. So if I want to energize this coil, how to then supply the neutral to this side and the live to this side, then this coil is going to energize. And the moment this coil energizes, these terminals, these are common terminals. This is C, common terminals. Meaning if I want to use any of this side, I have to then connect a live wire. I can loop the same live to this common. before I'll be able to use this side, the number 4 and number 8. And the same way, if I want to use this side, I have to then loop the live to number 9 before I'll be able to use this side and this side. That is the way the electromagnetic relay works. The moment it will receive the right voltage, that is the single phase voltage, and the maximum is 250 volts. The moment the coil receives set voltage, the normally open terminals are going to close and the normally closed terminals are going to open. Now we have number 9 as common. This number 9 is linking directly to number 1. This is NC, normally closed. And at the same time, it is also linking to number 5 as normally open. And the same way we have number 12 as common and number 4 as NC. And the same number 12 and number 8, NO. So the moment the coil receives the right voltage and it's energized, this bar that is linking directly to number 1 will come and link to this normally open contact we have here. And the same way, the moment it's energized, this normally closed, the bar will disconnect from this side and then come and link to number 8. That is how the electromagnetic relay works. I'm not going to talk more about this because I have electromagnetic relay video on YouTube and I'm going to leave that video link in this video description. So if you want to learn more about this, you have to then go to the description and then tap on that video link. I've explained all the things you need to know. It is also a practical video. So you're going to be seeing how the contact switches when it's energized. So guys, basically that is how it works. And the circuit that we are going to be working on, how to understand this before you can work on such a circuit. This side is for the wiring diagram of the circuit. The purpose of this video is to understand how a relay holding circuit works. Now, I have this lamp here. This is the lamp holder and this is the lamp. I want to turn on this lamp. In order for me to successfully turn it on, I have to do something called the hold on. The hold on is what is going to maintain the electromagnetic relay in its energization state when the start push button is being pressed. Without the hold on, the moment I remove my hand from the start push button, this lamp you see here is going to go off, but the moment I push it, this lamp is going to illuminate. It is the same principle as the contactor hold on, but this is also a different way of doing it. And I'm going to explain all of this to you. So stay tuned. And this is the wiring diagram. Now, I have this line here. This is the live. So what I have to do is to draw something like this. This is a circuit breaker. I'll make it C breaker. It's a circuit breaker. I have a single pole circuit breaker here for safety purposes. And the down here is where you're going to be seeing the normally closed push button. This is for stop. This is the stop push button, NC. Can also name this side 1 and 2. These are contacts. How to then connect a wire and screw it. And the down here is where you are going to be seeing the normally open switch. This is the normally open switch. We have it something like this. This is for start. This is the start push button. We have it as number 3 and number 4. Now, with these switches, this is stop and this is start. So when I turn on this circuit breaker, it is going to link to this one. This is the live. It's going to link. And from here straight to this side. This is normally closed. The stop is normally closed. 1 and 2 normally closed. So the current is going to be transferred from this side to this side, from here to this side. This is the start, the normally open. That is the green push button. This is the green. and this is the red at this side and the green at this side. So what I have to do is to draw the relay itself here. You have the relay, the electromagnetic relay. Okay. Now on the wire diagram that we have on the relay, we have number 14 as A2. That's the neutral. So this is 14. This is A2 neutral. And automatically this side is the A1. That is number 13. This is the neutral. Now, when I turn on the circuit breaker, current is then transferred from this side. It's going to be something like this, from this side to this side. And because this stop is normally closed, I have the stop here as normally closed 1 and 2. So then be transferred from this side to this terminal, and from here to this side. This is number 3. That is the start. We have number 3 and number 4 on this start push button. So the current is going to be trapped at this side. Now, when I push it, this bar you see here will come and link to this one and this one. And the current that is being trapped at number 3 is then transferred to this side, to A1. That is the live. And then we have the A2 connected with neutral. So the relay is going to energize. This is the relay coil. So I'll put relay here, coil. The relay is going to energize. But the moment I remove my hand, I push it, current is then transferred to A1. The moment I remove my hand, it's going to de-energize. The same principle like the magnetic contactor. But this time around, I've added this lamp to it to make things clear. I remove my hand from the start push button. So then come back to this place. This is normally open. The moment I release it, I remove my hand. So come back to its normal position. That is the normally open. And the relay is going to de-energize. But what we have to do is to connect this relay to control this lamp. When I push this start push button, the lamp is supposed to start working. I don't want it to go off when I remove my hand. So what I have to do is to do a hold on circuit. Before we go to the hold on, what we have to do is to include this lamp in the circuit. This part that I'm coming to draw is the lamp side. We have this line here. We have this side. This is normally open. Normally open. And down here, we have the lamp. This is the lamp. To the neutral. We have the neutral from here to this side. And this side is going to be live. Now, this normally open you are seeing here can be found on the electromagnetic relay. So what I have to put here is to write relay, meaning this normal open contact can be found on the relay. Now you see that we tap the live from this side, the main line. Another person can also bring it down here. It's the same principle, but I'm making things clear by tapping it from this side. This side you are seeing, meaning we have looped the live. Could be that we loop it from this side to any of the common. We have number 9 and number 12. So this side, let's say we used the number 9. So this side is going to be 9. And down here, we use normally open so that when the relay energize, then this open is going to close for a current to be constantly flowing to the lamp. So the normal open is number 5. So you can put here number 5. And this side is the common. We loop the live to one of the common terminal. That is number 9. And we use the normal open side. Number 5 and number 9 are normally open contact. You can see that we have it here. Number 9 and number 1 are linking directly to each other, so that is normally closed. And the same number 9 and number 5 are normally open. When it's energized, this close is going to disconnect, and then the bar will come and link to this side. That is how the relay works. Now with this drawing, the only challenge we are going to be facing is that when I push this start push button, you have the green here. When I push it, the relay is going to energize. Now, I've tapped the main live to number 9. So the moment this coil energizes, it will receive the rise voltage. That is the single phase voltage. And it's energized. Let me put lamp here. Here's the lamp. And it's energized. This normally open you see here. It is going to close. It's going to turn to something like this. It's going to close. And the current is then transferred from number 9. We have number 9 here. This is a contact. From number 9, this bar will come and link to this normal open contact. And then it will tend to normally close when it's energized. So the moment it's closed, current is then transferred to this side, one terminal of the lamp holder. And you have the neutral already connected to the lamp holder. So the moment I insert the lamp, it is going to work. This drawing represents a lamp. So this side is the live and this side is the neutral. Now, when I remove my hand, this lamp you see here is going to go off, but we don't want it like that. That is what we have here. So the only thing we have to do is to build a hold-on circuit. This hold-on is what is going to create a parallel flow of current when the start push button is being pushed. And aside this one, this electromagnetic relay you see here is having a diode. This is LED diode. The moment I push the start push button for it to come and link to this side, the diode you see here is going to light up, but the moment I remove my hand from the start push button, so then go off. And the lamp will also go off when connected. So what we have to do is to build a hold on. These components here are in series. This is a stop push button, one component. We have the circuit breaker, one component. We have the start push button, one component, and the electromagnetic relay itself as a device. All of them are in series. So the only thing we have to do is to do a hold on circuit. This is a hold on. This is what is going to create a parallel flow of current to the relay. And then the relay is going to maintain in the energization state, hence making the normal open that has turned to normally close to remain in that state. That is how it works. So this side, this is normally open. Another person can also do something like this. Now, this is normally open. This is a switch, normally open. This side you are seeing here can be found on the relay. This is a relay contact, normal open contact. And the same way another person can also do something like this, normal open. And this side too, as normally closed, something like this. It is the same thing. This drawing and this drawing, they are the same principle. Others says that these drawings are outmoded, these drawings, but it still works. So guys, that is that. If you see this normally open, don't think that is a different thing. This normally open is a relay contact. That is normally open. That is that. In the same way, you can draw the normally close as this. Normally close, a relay contact, normally close. Yes, something like this. It also works. So guys, that is that. Now, this hold-on circuit, the only thing you can do to do this hold-on circuit, you see that on the contactor, we have 13 and 14. That is for the hold-on. But on the relay, the only thing you have to do is to tap from number 3 to one side of the common. Over here, we use number 9 and number 5. In the same way, we can use number 12 and then number 8 as the normally open. So here, you tap it from this side, that is the start push button, 1 terminal, 2, number 12 on the relay. And then we used number 8 as the normal open, as this contact. So what I have to put here is number 8. As easy as that. And then name it, hold on. So guys, basically this is the wiring diagram of electromagnetic relay holding circuit. As simple as that. And as I said, from here, we are going to the practical side. That is where you are going to be seeing all the components wired. That is that. Stay tuned. So guys, this is the practical video. As I said, I have my single pole circuit breaker here, and this is a neutral connector. This is the live, and this is the neutral. This is actually a connector. I have my stop push button. This is the red push button. NC number 1 and number 2. Normally closed contact. I also have this stop push button here. Number 3 and number 4. Normally open contact. This is actually a switch. This is also a switch. And finally, the electromagnetic relay. This is the coil of the relay, and over here is the socket or the base. This is also my load. This is the lamp itself and a lamp holder. Now, without wasting much time, let's get right into the wiring. I have these drawings here. This is actually the wiring diagram that you have on the electromagnetic relay coil. You have it here. This wiring diagram, you have it on the side of this relay. And also the circuit wiring diagram. This is the circuit that you are coming to build, or the circuit that you are coming to wire. This is the wiring diagram of the circuit. We have this single pole circuit breaker here. Have it here. This is actually the live, and the down here is the neutral. So this is the circuit breaker, and over here is the stop push button. We have this red push button as our stop push button. Normally close. We also have this start push button here, number 3 and number 4. We have this green as the start. And finally, the relay coil, we have it here. We have A1 and A2. And A1 is number 13 and A2 is number 14. That is neutral, the A2, and the A1 is the live or the switch wire to the relay. And as I said earlier on this relay socket, we have numbers. This is the numbers that is going to help you to do the wiring. If I want to connect this A1, the wire, to number 13, what I have to do is to look for number 13 on this socket. That is what we are about to do. So stay tuned. And over here, this is normally close contact. This contact, as I said earlier on, can be found on this relay we have here. This contact is what is going to help us control this load. This is normally open contact, number 9 and number 5. We are also going to learn how useful this contact is. So let's get right into it. I also have this magnetic contactor here. And when we are done connecting this load, I'll disconnect the cables and then connect it to this magnetic contactor to see how it is going to work. So guys, stay tuned. What I will do is to connect this brown wire to the live from the breaker. The down here to number 1. That is the terminal we have on the stop push button, and from 2 to 3. This is the brown wire. Okay. We have number 1 at this side, so I'll connect it to number 1. This video is all about how to hold on electromagnetic relay. That is what we are doing. And you also have a load to connect it to it to see how important the electromagnetic holding circuit is. This is from number 2 to number 3. This is from number 2 to number 3. This is number 2, the wire connected to number 2, from 2 to 3. Our number 3 are this side. And from number 3, I have to connect a wire from 4 to A1. That is number 13 on the relay socket. This is from number 3. So what I have to do is to look for A1, that is number 13. And we have the 13 at this side. This terminal you see here is number 13. So I'll connect this wire to it. Okay guys, the only thing we have to do now is to connect the neutral. Now we have successfully connected the wire from the circuit breaker to the relay contacts number 13. That is A1. So what I have to do is to connect the neutral to A2. That is number 14. So what I will do is to use this blue wire from this connector to number 14. We have number 14 at this side. So I'll connect it to it. Guys, let me chip in this. We have this magnetic contactor here. On this contactor, we have number 13 and number 14 as the hold-on terminals, or the contact that's the hold-on wire is supposed to be connected to. But on this electromagnetic relay, we have different numbers, but they all obey the same principle or the same rule. So stay tuned. Now we are successfully done with half of the connection. So what I have to do is to turn on the circuit breaker. Now we have this start push button here. This is stop push button. The moment I turn on this circuit breaker, this bar you see here will come and link to this. And the current is then going to flow from here to number 1 and from number 1 to number 2. This is normally closed contacts or normally closed switch. That is the stop push button. So automatically when the circuit breaker closes, this 1 and 2 are linking to each other. We have this bar here. They are linking to each other. So the current is going to be transferred from 1 to 2 and from 2 to 3. So it's going to be trapped at this side, number 3. And when the start push button is being pushed, that is the green. When it is being pushed, this bar you see here will come and link to number 3 and number 4. And then the current is transferred to A1. That is number 13. And you already have the neutral connected. So this electromagnetic relay you see here is going to energize. Now, let me turn it on for us to see how it's going to work. You have it turned on. What I have to do is to energize it. You could see that the moment I remove my hand from this start push button, this LED indicator you see here, it also goes off. When I push it, it has energized. And right now, the normal open contact we have on this relay has closed. When the relay energized, this normally open you see, we have number 9 and number 5 as normally open. Number 12 and number 8 as normally open. Right now it has closed and number 1 and number 9 has open. That is how the relay works. The moment the relay receives the right voltage and it's energized, normally close is going to turn to normally open, and normally open is going to turn to normally close. Now look at this. The moment I remove my hand, it also goes off. The indicator has gone off, meaning a hold on is needed for it to be stable. The hold on is going to create a parallel flow of current to this electromagnetic relay. All these components are in series. So the moment I do something like this, the hold on from number 3 to number 12, from number 4 to number 8, it's going to create a parallel flow of current from this side to the A1. The moment I do this connection, the hold on connection, and push this start push button, the relay is going to energize. There's going to be a flow of current from 3 to 4 and from 4 to A1. And when I'm done with this side, automatically when the relay energized, this side is going to close. This is normally open. So it's going to close. There's going to be a flow of current from this side to the relay. But when I release, this 3 and 4 is going to serve as normal open. But because current has already flowed from this side to the relay, it is going to maintain in its energization state. Hence, making normally open to be closed and normally closed to be open. It's going to maintain in that state. All normally open is going to tend to close, and all normally close is going to tend to normally open when this electromagnetic relay energizes. Now, to understand this phenomenon very well, what I have to do is to do these connections and leave this. When I'm done with this, then we come back to this to see how important the electromagnetic relay holding circuit is. When I turn it on, the indicator lights up. When I release, it goes off. Safety first, so I'll turn off the circuit breaker. Okay. Now we have the live to this load tapped from this side. I made this connection for beginners to understand this circuit very well. Another person can also tap it from this side, the breaker side. And that is what I'm coming to do. You can tap it from here to this side. The circuit breaker we have here is for safety purposes. So you can tap from the down here to this side and to the load. But in the wiring, I tap it from here. But practically, I'm going to tap it from the down here to the load. So what I have to do is to use another brown wire and open this terminal. What I have to do is to connect this wire, this brown. Okay. Now, I have to look for number 9. This is number 9. And as I explained on the whiteboard, we have number 9 and number 12 as common contacts or common terminals. This drawing you see here is the same as 1-gang 2-way switch. We also have this side, the same as 1-gang 2-way switch. But this is electromagnetic relay. Now, we have number 9 and number 12 as common contacts. So if I want to use any of this, I have to then connect the live to number 12. That is the common terminal. If I want to use any of this side, I have to connect the live to number 9. That is how it works. So over here, I'm looping the live from the down here of the circuit breaker to number 9. We have number 9 at this side, meaning I'm going to use this side. This is normally open. So I'm going to make good use of this number 5 to the load. Now, we have the wire connected to the breaker. What I have to do is to look for number 9. We have number 9 at this side. So what I have to do is to connect this wire to it. Okay. We have the wire connected to number 9. And over here, we have normal open. And number 9 and number 5 are normally open contacts. So what I have to do is to use number 5 as we have here. So I'll use another brown wire and look for number 5. We have 5 at the back here. Okay. So guys, right now, this cable becomes our switch wire. We have the live from the breaker connected to number 9. This is the wire to number 9. And we have number 5 at this side. And this is number 5 to the lamp. So what I have to do is to connect it to the lamp holder and then the neutral also to the lamp holder. Have this switch wire. What I have to do is to use this blue cable and connect it to this connector. That is the neutral. Okay. We have 3 terminals. This terminal you see here is the earth. So if you have your earth wire, you can connect it to it. This side is the neutral. Okay. So guys, we are done with almost the wiring of the circuit. We have the load side connected. So what I'll do is to operate the circuit to see how these components are going to behave. Turn it on, push it. So guys, this is how the circuit is going to work without a hold on. This is how it is going to work. When I push it, I release, it goes off. So with this, if you want to use your load, your lamp or any other load, what you have to do is to push it and be standing there. Even if you want to sleep, how to push it and be there where the switch is. How to be there whilst you sleep. And we don't want this thing to happen. So what you have to do is to do something called the hold on. You could also see that when I push the start push button, this diode we have here has light up, telling you that the relay has energized. But the moment I release, it also goes off. This is without a hold on. How important it is to do a hold on circuit. So what we have to do is to do the hold on. That is going to hold the circuit for us. Safety first. Okay. As I said, the hold on we have here is going to create a parallel flow of current to electromagnetic relay. This is the relay coil. When it's energized, all normally open contacts are going to tend to close. How this as open, it's going to tend to close. The bar here come and link to this bar. This bar you see here will come and link to this bar. And all normally close is going to open. That is how the relay works. This bar is going to open. This is also going to open. So what I'll do is to quickly connect a wire from number 3 to 12 and from number 4 to 8. Something like the magnetic relay holding circuit. But these have different numbers and it is the same principle. So I have these wires here. This is also a brown wire. We have number 12 at this side. So what I will do is to open it and then connect the wire. Okay. I've connected it to number 12 already. So what I have to do is to connect it to number 3. I have number 3 on this side. This is the start push button. You have it here. The start, number 3. You can see that we have this line being tapped from this side to this side. In the same way, the 4 is being tapped to this side. And from number 4, I also use this brown wire. Okay. From number 4 to number 8. We have number 8 at this side. This is number 8. I'll connect it to that. Okay guys, we are successfully done with the whole wiring of the circuit. We have all the components needed to be connected. So what I'll do is to operate the circuit. Okay. This is the start push button. So right now the circuit is working perfectly. It's working the way we want it to work. With this, you can have a sound sleep. You can just push it one and then go to bed. Whenever you wake up, you then come back to this stop push button we have here. push it once and then it goes off. Either the lights or any other load, it goes off like that. I want to turn it on. So guys, that's the importance of the electromagnetic relay holding circuit. Without this, you cannot do anything. So it is very important to know how the wiring diagram and how to connect them in real life. And as I said earlier on, what I will do is to bring in this magnetic contactor and then disconnect the lamp holder and connect it to this magnetic contactor to see how it is going to also energize. Now, when I turn it on, you could also see that the LED indicator has light up, telling you that the electromagnetic relay has energized or it is working. So safety first, what I have to do is to turn off the circuit breaker and then connect it to this magnetic contactor we see here. We have A1 and A2. And A2 is the neutral terminal. So what I have to do is to connect this blue cable to A2. And the A1, connect this to it. This is the live or the switch wire. Okay. What I will do is to turn it on. This is the circuit breaker. You will see that this magnetic contactor you see here has energized and it is working perfectly. If you have any load, you can connect it to it, either a motor or any other thing. You can connect it. You have the inputs and the outputs. These are the power terminals or the power contacts. So guys, that is how to hold on electromagnetic relay. This is stop push button. We have this bar linking to this close contact. So when I push it, to push this bar back, and the moment I release it, so then come back to its normal position. It is going to serve as normally closed contact or normally closed terminal. And current is also transferred from here to number 3. That is how the stop push button works. So the moment I turn the load off, something like this. Right now, this bar you see here has disconnected this contact. That is 1 and 2. But the moment I release, so then come back to its normal position as normally closed contact. That is how it works. I turn it on. I stop it. I release. Right now it is serving as normally closed and current has been transferred to number 3 and number 12. So the moment it's energized, it will then flow from 3 to A1 and also from 12 to 8, from 8 to this contact and to A1. And the same way, this is normally open. So the moment I push it for the load to start or for the magnetic contactor to turn on, when I push it, this 3 and 4, the 3 will link to this contact and this 4 will link to this contact. But the moment I release, so then come back to its normal position as normally open. But because we have the hold on connected and the relay has energized already, there's going to be a current flowing from the back here to 4 and from 4 to A1. That is how it works. So the current is going to stop flowing from 3 to 4. Then pass the back here to A1. So simply, that is how to understand the working principle of this circuit or the stop push button and the start push button. So guys, that is that. See the indicator telling you that it has energized. I stop it. So guys, that is how to build electromagnetic relay hold-on circuit. And as I said earlier on, I have a video about electromagnetic relay. I'm going to leave the video link in this video description. If you want to learn more about this electromagnetic relay, just go to the description and tap on the link. It will take you directly to that video to watch it. It is a practical video. I've explained all the things you need to know, how the contact switches when it receives the right voltage. And you also have AC electromagnetic relay and DC electromagnetic relay. So whenever you are working on electromagnetic relay, how to look at the supply voltage to the electromagnetic relay coil. So basically, that is that. If you find this video helpful, consider subscribing to this channel and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Thank you for watching this video and see you in my next video.